Hello everyone, today we are going to start exercise 8.2. So question number 1 we are starting here, you can see the figure. So what we have given here is ABCD, a quadrilateral. So this is a given quadrilateral, ABCD, and we have given some midpoints like PQRS. So what do you mean by a midpoint? A midpoint bisect a line segment in two equal parts. So what we have given ultimately is AP equal to PB, BQ equal to CQ, CR equal to RD, DS equal to AS. So this is we have given, and what to prove is first part SR parallel to AC and SR is half of AC, and in the second part we have to prove that PQ and SR are equal, and in the third part we have to prove that PQRS is a parallelogram. So student, you have studied about midpoint theorem, MD midpoint theorem, so MDPT theorem. So in that theorem we have the proof that if we have in a triangle midpoint of one side, right, so the line joining to the other side to any point, this line is parallel to the third side of the triangle and also half of it. So let us start the proof of the first part. In the triangle ABC, you can see that the triangle ABC. This is your triangle ABC. We have given that P is the midpoint of this AB side. So by midpoint theorem we can say that this PQ is parallel to AC and also half of AC, right? So here we have PQ is parallel to AC and also half of AC. So ultimately you can do in the other triangle ADC also. So you can see the triangle ADC here. So this is your triangle ADC. This is your triangle ADC. In that S and this R are the midpoints, and the line joining these 2 points is parallel to the third side of the triangle. This is what the MDPT theorem you said. So this SR is parallel to AC and also half of this AC, right? So we will get this point. So PQ and AC are parallel and also PQ is half of AC. And similarly we can say that we have proved here also in the triangle ADC that SR is parallel to AC and also half of AC. So this is MDPT theorem, right? So midpoint theorem. So come to the second part, from 1 and 2 we can say that 1 is this, what 1 is said. Come to the figure. 1 said that your PQ is parallel to AC and half of AC. Second is said that SR is parallel to AC and also half of it. So what you can say that both are equal and parallel, because when SR is parallel to AC, PQ is parallel to AC, then SR and PQ are also parallel and equal, right? So from here we can get PQ equal to SR is the second point we have proved here. Now for the third point we are to prove that it is a parallelogram. You know that for the condition of parallelogram we need to prove that the opposite sides are parallel, right? So here you can come to the third part. You have proved that one pair of parallel sides are there. You have proved that PQ is equal to SR. You have proved PQ equal to SR and also PQ is parallel to SR. According to the definition of the parallelogram, we need one pair of parallel and equal sides so that the other will parallel and equal. So it is a parallelogram. So we can say that PQRS is a parallelogram. Now come to question number 2. There ABCD is the rhombus and PQRS are the midpoint of the AB, BC, CD and DA. And to prove PQRS is a rectangle. So join AC and BD. You can see AC and BD we are going to join here. And what we here we have to prove that this PQRS is a rhombus, right? Sorry, PQRS is a rectangle. Now start the proof. At first I am taking triangle ABC. This is your triangle ABC. In that P is the midpoint and Q is the midpoint. So you can say that PQ is half of AC and equal to AC, right? And in this triangle, this is ADC. In the triangle ADC you can say that S and R are midpoint, so that SR is parallel to AC and half of AC. So from 1 and 2 you can say that SR is parallel to PQ, that we have proved in the previous part also. So I'm directly writing here SR and AC are parallel, PQ and AC are parallel, so that both are parallel. So that we have proved in the previous part also. Now in the triangle ABD, you can see the triangle ABD. From here you can see the triangle ABD. This is your ABD. You know that S and P are the midpoints, so that this SP is parallel to this BD and half of BD. Now in the triangle this BDC, this Q and P are the midpoints, so that you can say this is R. So Q and R are the midpoints, so that you can say that QR is parallel to this BD and half of BD. So from 1 and 2, what you can say that your SP is parallel to QR and also equal. So here we have proved here that I taught you that by using 1 and 2. So what you can say that, so from 1 and 2, what you can say that we have proved that this is parallel to this and this is parallel to this, so that this is PQRS is a parallelogram. So first we have proved the parallelogram, but we are given to prove the rectangle. So what we need to show that this angle is 90 degree and this is also 90 degree, that we have to show here. So let us take this triangle and this triangle and let us show. So in SEOF you can see that SF and OE both are parallel because SR and AC are parallel, SE and FO are parallel because SP and BD are parallel. So we can say that this is a parallelogram. So by CPCT you can say that so by the opposite angles of the parallelogram 1 and 2 are equal. If 1 and 2 are equal, what it means, here we have 1 and 2, come to the figure, here we have 1 and 2, these are opposite angles of the parallelogram, so they are equal. And you know that if you add these two angles, if you add here you have given 1 and 2 are equal because ABCD is the rhombus and its diagonal bisect each other at 90 degree. So your 2 is 90 degree. If 2 is 90 degree, so 1 is 90 degree. So what you can say that and a parallelogram that have 90 degree angle is the rectangle, right? So come to the third question. What we have given, ABCD is the rectangle, PQRS are the midpoints of AB, BC, CD and DA. We have to prove that PQRS is a rhombus. So what we need to show here, we have to show the adjacent sides are equal in that figure. So let us start in the triangle. You can take this triangle. You can take a triangle ABC in that P and Q are midpoint, so that PQ is parallel to AC and half of AC. Now take triangle ADC in that S and R are the midpoint, so SR is parallel to AC and half of AC. So from 1 and 2, what you can say that SR and PQ are equal and parallel, right? So you can say that PQRS is a parallelogram. So what we need to prove here is the adjacent sides are equal. Here we have proved it is a parallelogram. Now in the triangle SAP and QBP, so we need to prove them congruent. So come to SAP and QPB, right? In these two, we know that ABCD is a rectangle, so angle A and B are equal of 90 degree. You know that S is the midpoint, P is the midpoint, Q is the midpoint. So you can say that SA equal to QB and AP equal to PB, right? So by CPCT, so these two triangles are congruent now. And now by CPCT you can say that SP equal to PQ, and SP and PQ are, you know, SP and PQ are adjacent sides of the parallelogram, and if adjacent sides of the parallelogram are equal, it is a rhombus. So PQRS is a rhombus. So that I taught is written here, you can see from here, right? Come to question number 4. Here you have given AB is parallel to, this is your AB is parallel to DC, okay, AB and DC are parallel, and what we have given DE, this DE and EA are equal, and EF is parallel to, this EF is parallel to AB, right? And we need to prove that F is the midpoint of BC, right? So we have to prove this F is midpoint of BC. Ultimately we want to show that this part FC is equal to BF, right? Now come to the proof. You can see in the figure here your AB is parallel to DC. AB and DC are parallel, right? AB and EF are also parallel, so that we have here AB parallel to EF, EF parallel to DC, so that you can say that all are parallel sides. So come to the triangle ABD. Now come to the triangle ABD. You can see here, this is your triangle ABD. E is the midpoint, so this EP is parallel to AB and also half of AB, right? And in triangle, so you can say that from this triangle, if E is the midpoint, and we have showed that this wall is parallel to this and half of it, so you can say that P is also midpoint. Now come to triangle BDC. In that we have taken P is the midpoint of the side BD. So by MPT you can say that midpoint theorem, you can say that this PF is parallel to DC and also half of DC, so that what it means, F is the midpoint. So F is the midpoint. So what I taught you, I have written here, so you can read from here. Now come to question number 5. In ABCD is a parallelogram. So you can see ABCD is a parallelogram, and we have to prove that BQ equal to QP equal to PD, right? We have to show all are equal. So let us start the proof. So you know that we have given AB is parallel to DC, right? And AB is also equal to DC. So you can take the half of both of the side. If they are equal, then their halves are also equal. So I have taken here halves of the AB and halves of the DC are parallel and equal both, right? And if they are parallel and equal, so what you can say that this AE is parallel to, come to the figure, your AE is parallel and equal to FC, because these are half of AB is AE and half of DC is FC. So right, so you can take AE is parallel and equal to FC, right? And you can say that now we have shown that these are parallel sides, these are parallel sides, and these we have proved parallel. So we can say that this this AEFC is a parallelogram, right? And if it is parallelogram, so you can take EC is parallel to AF. Now in the triangle ABD, come to the figure, you can see the triangle ABD. In the triangle ABD, right? So sorry, not in ABD, ABP. In this triangle, in triangle ABP, you have given E is the midpoint, so that your EQ is half of AP and parallel to AP. Similarly, you can do in the second triangle also. In the DEQ, your P is the midpoint, F is the midpoint, so FP is parallel to QC and also half of QC, right? And when you proved these two things, you can take from 1 and 2, you can say that from here you can say that if both are equal and parallel, so you can say that Q is the midpoint of BP and they are equal. Now come to the second part. In DQC, I told you PF and QC are parallel, I told you earlier, and P is the midpoint of DQ, so that you can say that QP and PD are equal. So from 1 and 2, you can say that all these three sides are, small sides are equal. Come to question number 6. This is ABCD is the parallel is a quadrilateral, in that where PQRS are the midpoints of AB, BC, CD and DA respectively. PR and QS bisect each other, right? PR and this PR and SQ bisect each other, right? What it means, this part is equal to this part and this is equal to this. Now join AC and PQ, QR, RS, SP, right? सबको आप join करेंगे, join these all. So you have to show that, you have to prove that okay, we have to show that PQ, PR and QS are bisecting each other, means we are ultimately going to show that this is equal to this and this is equal to this. Okay, now come to triangle ABC. Very easy. In the triangle ABC, you know that P is the midpoint, so this PQ is parallel to this AC and half of it. Similarly, in this triangle you can say these are parallel and half of SR is parallel to AC and half of it. So you can say that SR is parallel and equal to PQ. And similarly you can say that in the other triangle, right? So what you showed here, it is very easy to show that PQRS is a parallelogram. So diagonal of the parallelogram are bisecting each other, you know that. Diagonals of the parallelogram bisect each other. So it is very easy to show that this PQRS is a parallelogram. So you need to show that this is a parallelogram, and if it is parallelogram, these are the diagonals of the parallelogram, SQ and PR. So diagonals of the parallelogram bisect each other. Come to question number 7. This is ABC, angle C is 90 degree, D is the midpoint of AC, right? And we have to prove that AD is equal to this, AD equal to CD, and MD is perpendicular on AC, means we have to show that D angle is 90 degree. CM equal to this, CM equal to MA equal to half of AB, right? That we have to show here. So let us start. As you know that M is the midpoint, so you can say that if M is midpoint, so what you can say that AM equal to MB, and if M in the triangle, if M is the midpoint, you can say that this MD is parallel to BC and also half of BC. So you can say that if this is a midpoint, then D is also a midpoint and AD equal to AC. So this is AD equal to CD. So this is the first part that we have to prove. In the second part, BD is parallel to BC, we know that. So C plus D, when you do, this is 180 degree because all are so you can see here this angle C and D, if you add, this is 180 degree, and you know that this is 90 degree, one of them C is 90 degree, so D is also 90 degree, you can get from here. So you can prove that because D is the point where MD stands, so MD is perpendicular on AC. Now come to third part. In the triangle ADC and ADM and CDM, you need to prove them congruent. So this is your ADM and this is your CDM. So one thing is given here, DM is common in ADM and CDM. This 90 degree we can put, both are equal, and AD equal to DC because D is the midpoint. So by RHS or by SAS criteria, triangles become congruent, and by CPCT you can say that AM equal to CM, right? And also M is the midpoint, so AM equal to MB, so AM is half of AC also. So you have proved all the things that I taught you, I have written here, right? So I hope you understand what I taught. That's all for today.